We are moving away from simple disposal to really resource recovery, and it is really about the energy, it's about the carbon and the circularity. The residual waste is inevitable, but wasting it is not an option.
My name is Patrick Hübscher, and this is Circularity FM, the podcast about understanding, building, and managing circular business models.
Here we are at our second episode of the series Incineration in the Circular Economy. In the last episode, Philip Böhm, Managing Director of NEEW Ventures, took us on a tour through a waste incineration plant. If you ever wondered what happens to the waste in your garbage bin, you should definitely listen to that one. Today, we zoom out and talk about the contribution of such a plant to the circular economy, the energy system, and the role of waste to energy in carving out fossil fuels. If you want to get the key learnings from this conversation and an overview of upcoming circular economy events around the world, sign up for the Circularity FM newsletter. You can find it at www.circularity.fm. He's an engineer by training and worked for over a decade in energy sales already. 1.5 years ago, he joined EEW, where he is now the head of energy. Welcome, Sebastian.
Thank you very much, Patrick. Highly appreciate to be here.
Sebastian, we want to talk about energy, but let's first start with a personal perspective. When do you personally feel the most energetic?
Yeah, that is a good question. Business-wise, certainly on private terms, it's different, but business-wise, even in the past, it has always been just the interface between economical processes, between markets, and when this hits the physical constraints, that makes it really interesting to myself. So I like how markets are able to really find efficient ways of allocation. And this is something what obviously in the energy market, especially in the power market, is something what is really crucial. That's something what really energizes myself. We've seen already in the crisis 2022 in February in Ukraine, where EU took a lot of effort really to let the market run, even though they did subsidized on the one side and taxes on the other, but they still want to have the market. And that was, from my point of view, even though it created a lot of effort, what was the right decision, because this creates efficiency. And that energizes me, yes.
Okay. And is this like a single moment you can measure in minutes or hours? Because what you described to me as a fairly outsider sounds like a period of time that right now already lasts 4 years. So are you at your highest energy level since 4 years already, or how does that fluctuate?
Treat it as a constant flow of energy. That's how I really keep it. And even though there are obviously peaks in it, special market phases are kind of more energizing. You need to put more effort in it. And what we see currently in the crisis in Ukraine is certainly a very dramatic situation. But from a market perspective, this is always something what puts you more effort into analyzing, into creating decisions out of it. And it's kind of also energizing to myself as well in these situations.
Yeah, cool. Fortunately, you seem to have the right job for that. Yeah.
I still cope though. Did the right thing. And it's also good to be at EW, and we have lots of potential and great people around us that really makes it a lot of fun.
Yeah. Sebastian, 1 week ago, Philip took me on a visit to Premnitz, and he showed me and us and the listeners how a waste to energy plant actually works. Today, we want to zoom out a bit and talk about the overall business model and where waste to energy sits in the energy system, but also in the circular economy. So let's kick off that conversation with the overall question: what's the role of waste incineration in the circular economy?
What's the role in the circular economy? Let me put it very simple. From my personal point of view, even in the fully circular economy, there will be the residual waste, and this will remain. So there's no real way around it. But the really crucial question now is, do we waste it, or are we able to use it intelligently? That is the point. And if you're asking about our role as, for example, EEW with our waste incineration plants in Germany, we have a very specific role. You can probably summarize it very much as CRITIS, the critical infrastructure. That's what we are, since we offer a safe treatment of waste, which is really crucial in order to avoid all the circumstances which are connected to if you can't have any proper waste treatment and the waste is around the streets, etc. That's obviously also why we are CRITIS. The second role, and a very important role, is the energy generation. We do produce energy. So that was why I asked, do we want to waste it? No, we take waste as a resource, and the resource is being converted to energy, and this may lead to power, to heat, and to steam. Also a very important role. And the last point from these three is the material recovery. Once we are able to burn the waste, it's obviously part of the waste are really potential resources. There are different kind of metals in it, etc. And these are produced or more or less converted from the incineration process. And everything what is recovered from the burning part can be recovered and it goes back into the value chain. So that's, from my point of view, our role in the circular economy. We are moving away from simple disposal to resource recovery, with huge impact to our business model as well as to society and to circular economy. And it is really about the energy, it's about the carbon and the circularity. Residual waste is inevitable, but wasting it is not an option.
Right. So technically, it's a pragmatic approach where for you, what others regard as waste is not waste, it's a resource where you get as much energy out of it, or sometimes even like metals or other resources, but mainly energy. And let's say not waste the waste.
That's not waste, exactly. That's the punching line for it.
Yeah. Okay. So this is a bit the macroeconomic and circular view. We also want to talk about the business model. What's the model behind waste to energy for EW?
Right. Even our name states it very good. Energy from waste. So you can imagine that this already has something to do with our business model. But to put it very simple, we are on disposal for burning waste, and we get actually the fee for it. There are municipals and different counterparties which need to get rid of the waste. This, in ideal cases, are recycled before. So everything which is valuable should have been taken out of it before. And yeah, then we get the waste to our plants. We get a gate fee for it. And once we burn it, we have different factors of output. And these output factors are quite valuable. So that also plays into our business model. The output is electricity. We produce electricity. We have on turbines and on generators and are able to produce this for the grid. As well as part of the thermal process, we have heat. Heat is something you usually use for classical process in warm water or heating of living districts. That is possible. And the last opportunity for an additional value stream, part of our business model, is the steam. Steam is also something which can be used in different processes as well. So these are the key factors of our business model. We have obviously a very crucial responsibility in society, as everyone will see what's going to happen if the rubbish doesn't get rid of the streets and still plays a role there, or it will be dumped somewhere else, which isn't really an option for us. So yeah, we get it, we burn it, and we have different kind of resources afterwards.
And on the revenue side, you mentioned the gate fees. Is it stable? Do you get the same fees for the same kind of waste, or are there different kinds of waste that also make a difference in terms of the fees?
Yeah. Well, the market for waste is a market which also has demand and supply in itself. So there are times where you have probably recessions where not as much waste is accessible. All these different times of availability and supply and demand curve do have an actual impact on the gate fee. That is something which isn't that much predictable. things like economic crisis in 2008 or 9, or Corona, or maybe Iran. No one is expected, and these have an impact on what's going to be produced on the waste side.
Okay. And so far about the revenue side of the business model. On the cost side, what are main cost positions? I imagine EW does have costs.
Yeah, of course, we do have costs. Yeah, once you own and use a plant, that obviously is not getting younger. You use it for a thermal process, so the entire maintenance costs are certainly a very significant part of our cost. We are very qualified and very highly qualified colleagues in our rows, from engineers to technicians to people at the office, which do actually make it sure that we can deliver the process we have sold. But these are probably what's majorly drives our balance sheet. It's the cost from keeping our plants alive, letting them run, as well as very qualified personnel. That's probably the main drivers of our business model today.
Okay. Can you give also a rough indication about the importance of like carbon credits? I assume EW has to pay for the emissions that's caused by the waste. Is it relevant on the cost side?
Oh, yeah, very much relevant. The thing about taking the credits, or more or less putting the CO2 in the atmosphere, is something which obviously comes about in our process, but we are not those who really create the waste. So in most cases, the customers do actually pay the fee for the CO2, but the market itself is a very highly regulated market. We have different regimes. We came into BHG. We're facing, at least it's within discussion, but postponed to go into the ETS2. So these are different markets, kind of mechanisms which try to avoid additional CO2 emissions, which does totally make sense. We get it. We actually would like to reduce our CO2 footprint as much as possible, but it comes about in a process of burning waste we're receiving from others. We have invested, we have created different techniques of capturing the CO2 from the steam gas, and these do work, but it's highly costly to do so. You have to put a lot of energy into it to separate the CO2, and even the models behind it. What can you do with it? Will you storage, or will you utilize it? These models are very costly, and there are no mechanisms so far to really be able to do so on large scale. To come to your question, yes, CO2 has a major impact. Our customers and we try to reduce the CO2 impact as much as possible, but we always see where it comes from, and it's not from us. We actually only burn it.
Yeah. Okay. And we will have a deep dive on carbon capture with Jörn Jakob in one of the upcoming episodes anyway, and also with Fabian Böhmer as head of circularity on the report and ETS and the carbon. Let's come back to the energy dimension. EW and any other company operating in that field get gate fees, and you get paid for the energy you produced. And you already mentioned at the beginning, we're kind of living in interesting times, to put it in a neutral way. So the energy market is pretty dynamic these days, weeks, years, for geopolitical reasons, but also for reasons of climate change and energy transformation. So let's start with this overall transformation. What are the consequences of this transition from fossil fuels to renewable energy for a waste incineration operator like EW?
Yeah, Patrick, it is not just one consequence. So we've started in Germany with the Energiewende, the energy transition. This is actually a huge process, which has not been totally delivered in 5 years, in 10 years. This is an ongoing process, which already lasts since probably 2000 in Germany. I would say energy has become a much higher value itself. If we look on an incineration process where we win heat, where we win steam and electricity, we can actually treat the waste as a very high, or more or less a high valuable resource, which can be converted into energy. And in this transition process, all kinds of energy have a huge impact on the availability and even the possibility to transform the entire system. Let's start with heat. Heat in district heating is something what can substitute classical fossil gas. You don't need any extra power once you are able to have heat from a thermal process. So in this transition, heat, especially heating in larger areas, really has a high value, as well as steam. Steam is used in chemical processes. It's been used in industrial processes around food, as well as in different other manufacturing processes. And that's something what probably in the history has not been so much valued. You look very much into where's the next Autobahn, where's the opportunity to have good transport. But this is something probably today you would look at differently. If you're able to be around one of our sites, you can have steam, which is green steam, which can be used for your processes, and that at an attractive pricing. So it really is an advantage of your location if you maybe, for example, around one of our sites. That's something what is also an implication. The value of heat, the value of steam, and as well as the value of electricity. Electricity in the conversion from, or more or less going away from fossil fuels into more of a way with the more renewables in the system has also a big impact. Let's look at the forecast. We expect something around 400 gigawatts of renewable capacity by 2030. In the same time, the nuclear is gone, the coal is being phased out, and we have the attempt to have the entire system much more clean. On the other side, we obviously have aspects like EVs, more mobility applications. We have heat pumps. We have huge demand which is expected from data centers, something roughly about 15 gigawatts at least. That's the current expectation. We want to have green hydrogen, so we need electrolyzation capacity. All these do lift the current peak situation, the peak demand in the network of 70 to 80 gigawatts to expected 150 gigawatts. So higher need, more need of electricity, and this combined with the generation of more or less more renewables in the system shows the entire shift of the structure which has been where the power has been produced centralized and delivered from the different grid areas to the customer. Now it's being produced decentralized and also used decentralized. So entire different system. And the big change is that in the past, the production was very much stable. Yeah, there were different plants which were able to go for peak demands, but that what we call the base load was produced by different facilities which are mainly driven either by nuclear or by coal. So these are more or less gone, and we have renewables on the other side. And the effect was basically, and that's what you ask for, is a much higher volatility in the market from 50 minutes to 50 minutes. If you look on the negative hours, which is maybe quite a good indicator, in 2023, we had roughly 300 hours of negative pricing. So there was less demand than supply. In 2024, it was about more than 450 hours. And the expectation, even in the next years, is something between 600 and maybe more than 1,000 hours, which will be on negative pricing. So how the loop comes about to EEW. Now we need to look into the future. The value of being able to produce electricity whenever it's needed has a total different value now. So we look at this issue very intensively. We try to flexibilize our production. We have included battery storage systems. Patrick, I'm sure you've seen it in Premnitz on our sites. So we really need to be able to produce the electricity whenever it's needed in the market. And that shows flexibility on our side. We still need to burn the waste and whenever it comes, but have to find different ways of reacting into these market signals and different ways to support the Energiewende, to support the energy transition. And that is a big challenge for us, I can assure you. But it's worth it. It's worth it, since all of us are still heading for this big goal of supporting a renewable society, renewable industry in Germany.
Okay, basically, because of the phase out of fossil fuels, there is a higher demand and also more appreciation and attention on energy from waste. And on top of that, since the supply and demand is changing, there is a higher need for flexibility, which also puts some pressure and changing demands on EEW.
Yeah. On a punchline, Patrick, flexibility is the new baseload, and the system does not have an energy problem and has a timing problem.
And let's unwrap that a bit based on the three kinds of energy you mentioned. Let's start with steam. You already mentioned it a bit, but what do you mean by steam in terms of temperature or humidity? And can you give one or two examples of companies using it?
Yeah, of course. If you look into steam, we're looking onto different temperatures as well as different pressures. And these, you wouldn't go for any standard. Yeah. More or less look on the different applications you see on your customer side. And then you have roughly temperatures of close to 300 degrees. And pressure is about 35. That's what you see basically. And yeah, there are different customers with different needs. On one of our sites, Defzijl in the Netherlands, we are integrated in a chemical park. So in these chemical processes, our customers need the steam on a different temperature and a different pressure level to use it in their chemical processes. That's what they need it for. And yeah, all different applications from chemicals to food. That's what we basically see our customers sharing.
Okay, and this is basically also kind of an infrastructure decision. You mentioned already that some companies who are in closer proximity to a waste to energy site benefit from this steam, which you probably can't transport across 100 kilometers. You have to be close to a plant to keep the pressure and the temperature.
Totally right. Yeah, it's always pipeline driven. You always need to build a pipeline for heat as well as for steam. So if you look in the steam process in a site, mainly they are above ground for all different pressure streams. If you look on a middle pressure, it's something about 5 to 20 bar and 160 to 220 degrees. That's the basic range. The high pressure is something about 20 to 80 bar, as well as 220 to 480 degrees. These are always connected by pipeline systems. They're above ground. If you look into district heating, yeah, we have levels around something 110 degrees. That's not untypical. And here you also need civil works, civil engineering, and these are underground. So yeah, it's always quite a lot of infrastructure you need to be able to deliver heat or steam to the end customer.
And when you say district heat, this is basically the heat that goes into the flats.
That's housing, exactly, for warm water or as well as for classical heat in the house or in the roofs.
Okay. And you mentioned flexibility is the new baseload. Is there also increasing need for flexibility when it comes to steam and heat provisioning?
I wouldn't say it's an increased need for flexibility because people need to heat their house whenever it's cold. Industrial processes, chemicals as well as in food, they need the steam whenever the process does afford it. So the flexibility isn't really there. But once you want to flexibilize your power production, you need flexibility in steam and heating. And this can also be done by additional flexibility providers. Yeah, you can have different storage system. It doesn't necessarily have to be power storage system. It can also be heat storage system, which helps to really be able to decouple the heat, the steam with electricity production. For the customer, they don't need the flexibility. It's us who need the flexibility. And obviously, we discuss this with our customers as well, whether they can offer us any flexibility so we can use it in the electricity market to make the energy transition to make it work. But once they are very much process driven, it only helps to decouple the electricity production from the heat and steam, and this by any kind of technique to provide storage.
Okay. And last question on steam and heat. there is, at least in Germany, this ongoing debate again about phasing out fossil fuels when it comes to heating, and cities are supposed to have energy transition plans. Is there actually already an increasing demand from cities, municipalities to consume heat for their citizens?
Yeah. We have in Germany something which is called the kommunale Wärmeplanung. Yeah. So in all communes, there is a big plan of where is heat being produced and where is the offtake. So with this picture, the municipality is in the responsibility to have a good idea of bringing these two, the supply and demand, together. And that is the point where they come to us and ask, hey, dear EEW, is there any flexibility in your current plant? If yes, that's the best answer. Yeah. Then we look on the distances. How far is it away? Yeah. What is the effort for a pipeline system? Is it affordable? Can you make it go? If you don't have any flexibility and don't have any additional heat, you always look into opportunities how you can produce additional heat. That's something what we're doing in Großrechen with a heat pump, additional heat pump on site. That could be possible. Yeah. So whenever there's the need, and most of the municipals have the need to make their entire system green, they come to us and ask for the green heat. And yeah, whenever we have flexibility, they're pretty happy to take it from us. So that is an entire game changer.
Okay, cool. Good to know. And now comes again electricity. And you mentioned this is where flexibility is highly needed. To make sure we understand it correctly, so does EW provide energy to the grid and then to the whole system? Or are there also constellations where it's embedded in an industrial park, or you have specific contracts with companies just producing nearby? Is both happening? Does it play a role, or how does it actually work?
Yeah, both things happen. Heat and steam is always a local product. The power can either be sold on site to customers which are very close to connected. That's something what works, as well as we sell it to the grid. Grid is the case where the flexibility really is needed. On site, it's more or less of a low price. That's what the current customers look for. So both things work. And yeah, none of our sites is always the same. Yeah, they look different. They have different restraints. They have different customers. And yeah, whenever there's an advantage of selling the energy on site, that's something what we do. Otherwise, it goes into the grid. And the grid, obviously, the need for the flexibility is very high.
Okay. And then let's look at the topic of flexibility. So if I just reflect upon the, let's say, incoming waste stream that is more or less stable, I guess, depending on sometimes the types of waste. Of course, if it's shortly after Christmas, yeah, you get a lot of packaging waste, or if the gardening season starts, you get flower pots and so on. So there are probably some peaks. But I guess in comparison to the flexibility in the energy grid, you need to balance that a bit. How can you make this flexibility happen?
First of all, you need to be able to price the flexibility. You need to be able to trade it. Otherwise, you can't use it. So that's something of crucial infrastructure which has to be done on your own side. Once you're able to do so, you can predict, you can forecast. You look on the flexibility on our different sites. The boldest thing would be to reduce the capacity of the plant. Yeah, to really run it lower on a lower capacity. That's something what always works. But yeah, you always have to fulfill your contracts on the waste side. So as long as you're fully booked, there's not much of a flexibility. That's what you're intended already in the question. Then you look into different techniques. So maybe you are able to use more energy on the generator and less for heat or steam. Either because you have flexibility on a storage, or you discussed the option with your customer, or you use the capacity of a network. Yeah, especially a heat network has a different capacity, and you can sometimes run it a bit higher or a little bit lower. That is a creator of flexibility. You look in all different options without getting rid of the energy. Yeah, that's not an option. You don't want to waste it. use the flexibility you have on site from contracts, from storage, from network. So that's what you look at, basically. In extreme scenarios, and maybe for a couple of days, negative prices. Maybe you would even look onto not producing and putting waste into the storage and maybe burning it later when the market needs more of the electricity. As well, that is an option what you could take as long as you're able to predict and forecast and then make the right decision for obviously ourselves as a company, but as well for the entire network and the requirements we have there.
Okay. Sounds like a tough cookie and a nice riddle and puzzle to solve
Very much puzzle.
internally.
That has to only be done by lots of intelligence, and that's not something what you have in your own mind. These digitized processes which work in behind.
Yeah, definitely can imagine that. Sebastian, my last question is on that, but more from the perspective of the listeners who mostly sit on the consumer side of energy, either in companies or as private persons. So is there one thing consumers can do to speed up this transition to a more efficient and flexible energy system?
Yeah, that is actually a very good question. What can customers do? I think the first thing would be to really look into their own flexibility. Knowing what the history has been, that electricity always has been there and you can use it whenever you want, that time is certainly gone. So whoever has flexibility will help the entire system to become or to go a large step into our energy transition, as well as obviously reducing the consumption of energy itself, either on the fossil side as well on the power side. So reducing is probably the best answer to it. I know that most of the customers already have really benchmarked their potential and have very ambitious targets for what they're going to do and how to save energy. I think it's the combination of reducing as well as doing measurements to flexibilize and help, therefore, the entire market to be more efficient. If not so, the entire overall cost will certainly be a factor in Germany, since we need even more capacity on the renewable side, which is only used to the times of solar and wind. In the other times, they're not used. And we need a lot of investment in the entire grid to do so. So to avoid these costs, all of us should be really tempted to reduce the consumption and maximize the availability of flexibility.
Okay, and I mean, this also makes, from a commercial point of view, totally sense. If you reduce, you reduce costs, and I guess also flexibility, of course, requires a couple of investments, but there is a benefit, also commercial benefit, in having my consumption flexible.
Totally agree.
Sebastian, thanks for giving that overview and sharing your insights about this pretty energetic topic.
Patrick, thank you very much. Highly appreciated to be here and I had a good time. Thank you.
This was the second episode in our series, Incineration in the Circular Economy. If you want to get the key learnings from this conversation and an overview of upcoming circular economy events, sign up for the Circularity FM newsletter. You can find it at www.circularity.fm. In the next episode, we will see how the waste process can be more digital and transparent and how this helps to get more energy from waste. Until then, let's drive a profitable circular economy. And please don't forget, the most abundant renewable resource is your imagination.
My name is Patrick Hübscher, and this is Circularity FM, the podcast about understanding, building, and managing circular business models.